Good morning, everybody, and welcome back to Next Door NetAdmin. Today is a reader request. We've been asked to discuss OSPF, specifically how and why. I'm going to start with something a little different, which is what? What is OSPF, for those who don't know? So, let's start with routers. We know what routers are, right? They send packets from point to point, and that's how we get internet most of the time, right? We all have a router in the house. Most of us know what that is, conceptually anyway. Big routers, by which I mean in enterprise networks, routers are a little more complex than the little home gateway router that you're familiar with, which probably has wireless built in and probably has a few switch ports in it as well. But how do routers know where to send traffic? I've covered this briefly in a different video that was more focused on how does a router make selections on where packets should go. But how does it get that information? Quite simply, routers talk to themselves. Not to themselves, although they probably do that too. Routers talk to each other is what I meant to say. And there's a couple ways that you can do that. We're going to talk very briefly about routing protocols, which is how they exchange information about what destinations they can reach, and then how they make their decisions on which routes they want to install into the routing table. So, conceptually, you can break these down in a couple of different ways. There are exterior gateway protocols, of which there's really only one of note, and that's BGP. Fantastically complicated, not going to cover that in any way, shape, or form today. And then there's interior gateway protocols. OSPF is one of those. Within interior gateway protocols, you can also break it down into distance vector or link state algorithms. Distance vector, really easy to understand. It's at its most basic. You can get more complicated, but at its most basic, it is just a matter of how many different routers do I have to hop through before I get to my final destination. And it'll just say, okay, so the lowest hop count is objectively the better route because I'm going through fewer intermediate systems. Yes and no. If you have two routers to go through that are all connected by gigabit, that's still going to be faster than going through one router which is running on a 1.5 megabit T1 line. So distance vector can be misleading, and you can, like I said, extend that a little bit and add those other factors in there so that it has a better appreciation for the factors that it should weigh along the route. But link state, on the other hand, is entirely concerned with the links in between routers. Not so much how many different systems do I have to go through, but what are the links? What is each individual link's cost, speed? What is the link's state? Is it up? Is it down? How do we do this? OSPF is one of these protocols. It is a link state interior gateway routing protocol. Try saying that 5 times fast. OSPF stands for Open Shortest Path First. The open part, pretty basic. It's an open protocol. It's not patented by anybody. Nobody's getting royalties from it. It's there for everybody to use. Shortest Path First is the name of essentially the algorithm that we're using, although you may also hear it referred to as Dijkstra's. It's one of those pronunciations, but I'm not sure with Dijkstra's algorithm. Might be Dijkstra's algorithm. I don't know. Regardless, the principle behind it is right there in the name. Take the shortest path first. However, shortest is defined. That might be 5 links at gigabit over 1 link at 1 megabit. But however you construct the shortest path, take the shortest path first. If one of the links in that path goes down, take the next shortest path that is still available and connected to your destination. Pretty simple to understand. Implementing this, however, is not always as simple as you might hope. Like most things in the network, not quite as simple as you might have hoped. So why do we use this? Well, quite simply, in an enterprise network where you have many routers connecting many different sites, there's too many options, generally speaking, for an admin to want to manually define every single one. If you're looking after a company that has 100 different sites or more, different offices, they're all connected in various ways to each other. Maybe this office has connections to 5 others. Maybe this office has connections to 7. Maybe this one only has connections to 2 or 3. Actually figuring out how to get the traffic from point A to point B for any arbitrary A and B might be just simply too complicated. Too complicated. And if you have 100 different sites, each of which connects to the other 99, there's no way. There's no way you're ever going to be able to manually make all the decisions on exactly where this should go. This is why you have a routing protocol in the first place. So that if you just configure the routers to talk to each other, then they can figure out themselves what the shortest path is, and they can work around, oh, this particular link is down, we can still reach the destination by going through another, detour, essentially. We can take a detour through the network. Cool. How likely are you to actually encounter this in practice? I would argue not that likely. Think about how this is supposed to be constructed, just for a moment. Normally, these days, you have a bunch of sites, and they are given an internet connection. And when you have the internet connection, you say, use this internet connection, and then you'll have a VPN functioning between the various sites. Okay. If you do that, then your VPN, in and of itself, has to know where the traffic is going. Because it has to know, hey, when I get traffic for site A, I need to send it over this link going that way. If I get traffic for site B, I have to send it over that link going that way. And you don't really get as much of an opportunity to bounce it through varying tunnels because traffic selection can get a little tricky at that point. But if you have a small business or even a medium-sized business with some types of architecture, you can get away with just defining it all manually. And we do. Working at an MSP, we look after lots of small businesses and lots of medium-sized businesses. We're not using a dynamic routing protocol anywhere. I can tell you that right now. But that's because it's of a level where it's still reasonable to define it in terms of administrator-defined static routes. If you have a small business, it has one office, the only route you need is one route out to the rest of the world. Go out through your internet provider. Even if you have 2 different internet providers, conceptually, you're still going, go out to the rest of the world, either through this ISP or through this ISP. Pick one, depending on which one's up, or round robin them even if you really want. Use them both at the same time. But the rest of the world is that away. None of it is, it's just, you don't have to worry about different destinations. It's just the rest of the world. If you have 5 different locations, that is still workable in full mesh, but you don't actually have to do full mesh for the most part, because each site only has one link to the rest of the world. It's the ISP. And do they need to actually reach resources at each one of the other 4 sites? Most of the time they don't. Most of the time you have one main site or one data center that has all the information that you need, and then you have branch offices. They don't have their own servers. They don't have their, or if they do, they're just small servers for DNS and maybe print server. But they don't have a file server that other sites are trying to access, because that would make it more of a main site, and businesses try to co-locate those as much as they can. So, while each branch office may only have one internet connection, and the rest of the world is through that, the VPN really doesn't even have to go between all the different sites. It really only has to go from each branch office to the main data center. And that's the only link that they really need to worry about. It's the only link that we really need to worry about as network admins. Again, that's for small businesses. And you can do an extended star topology like this, where if you have, let's say, 3 main data centers, okay, these 3 main data centers all need to be able to talk to each other. Cool. But then each one is mostly responsible for branch offices in one section of the country or another. So primarily, all they need to do is talk to their nearest data center, and then the data centers will exchange information among themselves. So for the most part, even if you needed a branch office to hit multiple sites, they only need to hit they only need to hit 3 main data centers. They don't need to hit every other one of the 10 branch offices out there. So within reason, you can set up static routes and just do this all as administrator defined. It's fine. So then why is a routing protocol like OSPF actually needed these days at all? Where it's needed is when you're not using the internet as the internet. I'll explain what I mean by that. Typically speaking, what we're doing is I have one office and then I'm doing the internet. If I need to specifically reach a data center or something where the traffic needs to be protected, I can use a VPN, but it's still going over the internet. All I'm doing conceptually is taking information, packaging it up, and then shoveling it out this one link towards the internet at large, and I'm letting the internet figure out how does it get from point A to point B through all the routers that are there. But what if your internet link is not being used as the internet? It used to be a very common thing that for larger businesses, you would rent an actual exclusively accessed line from point A to point B. And it was dedicated only to your organization's traffic. It might have been over a serial link. This was very, very, very common, and that's still fairly common to see in testing diagrams and demonstration diagrams when you're actually playing with these protocols. They're often represented as serial links because that's what it always used to be. These days, you can get other services from an ISP, something, for example, called MPLS, multi-protocol layer. I want to say multi-protocol layer switching. I don't know if that's actually correct. Don't quote me on it. But MPLS essentially creates a virtual link from point A to point B in the same way that it would be exclusively accessed before, and secures it through an ISP's network. Specifically through an ISP's network. If you have one site that is on Comcast and one site that is on TELUS, you can't do an MPLS link between them. They both have to be on the same ISP. And so the MPLS link will take it through the ISP's network, and you can do things like addressing a remote subnet as if it was local, and it'll just go through the link as if it was a local link. And so everything can be addressed internally without having to worry about, is it going through the VPN? Does the internet? You don't worry about all of that because the ISP is doing that for you. And if you have 100 plus sites, if you are a company the size of Microsoft, for example, you're going to be using this kind of a service. It's also going to be very expensive, but at that size, you can afford it. So when that is the case, this is when routing protocols start to come into their own. Because you're not just trying to say, send everything out this link to the internet, and then it'll go through a VPN to wherever it needs to go. You've got a service that conceptually means you can reach everything else as if it was internal. And so now, if everything is internal, then all of your routers are participating in sending local traffic between the sites. And that's when you need to start figuring out, can this site talk directly to that site? Or does it go through, another site completely? And that's where you get a dynamic routing protocol like OSPF. Now, OSPF has a lot of complication to it. And I'm not going to be able to cover all of it today. But let's start with the concept of OSPF areas. An OSPF area, technically speaking, is a 32-bit number. It's often represented in dotted decimal notation, if it's not just a decimal. But that means it looks like an IP address, but it is not actually an IP address. It might look like it, but it's not. Area 0 is where everything starts. Area 0 in OSPF is considered the backbone area. Within the backbone area, everything should be able to talk to everything else because it's the backbone. It's the core of the network, if you will. So, Area 0, the big bad one. Other links might be in different areas. And this is an important thing. The areas are bounded by routers. A router is not a member of one area just because it's a router. If all of its interfaces are in the same area, fine, then the router is only in one area. But a router can be part of multiple areas, as many areas as it has interfaces, really. OSPF also assumes that within an area, everything can talk to each other. So you can't have a discontiguous area 0. You can't have these 5 are in area 0, and then it goes through something else, and then there's another, part of the backbone over here. It doesn't work that way. Or it didn't at first. And then we came up with things like virtual links to virtually connect Area 0 over something that's in between. That's even more advanced. Right now, we're still focused on areas. So you have Area 0, the backbone area. There are different area types. Any router that is sitting in between two different areas has one interface, say, to Area 0, and then one interface to Area 2. This becomes known as an ABR, Area Border Router. It's sitting on the border between two different areas. Fairly simple. Within an area, the routes are exchanged just as they are. But when you're crossing between areas, the router that's on the area border summarizes the routes and passes it in there. It may not pass every single route because that's unnecessary. You just pass the summaries over. You might also have an ASBR, which is an autonomous system border router. This sits on the edge of the network. It handles OSPF within the organization, but it also sits on the edge of your autonomous system. And an autonomous system is just a way of saying it's a group of machines and networks that are under one single administrative control. One single administrative unit, that's an autonomous system. So when you're on the edge of that, you're talking to the rest of the world under a different administrator's control. That's what that is. And so the areas that you can have include things like a stub area. A stub area doesn't need to know all the details. It doesn't even need to know all the summaries. It's just a little stub. It's not connected to anything else. So in that case, all you might need to pass in there is a default route. To reach the rest of the world, send this way into the network. That's all you need to send it. You might also have a not so stubby area. This is a Cisco extension that was supplied and widely adopted after a while, which, as far as OSPF is concerned, might be a stub area. But it's not so stubby because maybe it has an ASBR in it, bordering another autonomous system. And so OSPF can say, I only need to give you a default route, but it still needs to be able to accept other routes that might be inbound from another autonomous system. Okay, fine. Then you can have a totally stubby area, and then, in an amazing oxymoron that network admins seem to enjoy from time to time, a totally not so stubby area. I don't get why we made one of those. We just did. Fine. Each one of these area types has different restrictions and different abilities that go with it, which in practice makes organizing OSPF a little bit of a thought exercise and a little bit of experimentation too. But for all of that, OSPF, if I actually had to run an interior gateway protocol, OSPF would be my protocol of choice. It's the first one that I would go to. It's worth noting that OSPF is generally used more by enterprise and business groups, large businesses is what I want to say. But if you're talking about an ISP organizing its network, there's a different protocol that is often used, and it's called ISIS. Yes, that spells ISIS, But specifically in this case, what it stands for is intermediate system to intermediate system, IS-IS. Within an ISP, that's more commonplace. But on the business side, even though most of the time, all the time, frankly, in the last 15 years, I've been able to use static routes. If I had to use an actual dynamic routing protocol, OSPF would be my protocol of choice. But putting it together can really twist your brain up sometimes. So for now, I think that's all I'm going to cover for today, just because that's already quite a bit of information and quite a bit of talking. So that's basically been OSPF. What is it? Why is it? And what are some of the things that you can expect to see in OSPF? So hopefully you found that interesting, or at least mildly thought-provoking. Hopefully it didn't twist your brain up too much. But next week, I'll look at how do we actually implement OSPF if we wanted to on a basic level. Enough to get you started anyway. So again, hopefully you found that interesting. Thank you very much for watching. If you have any other suggestions on topics you'd like me to cover, feel free to let me know down in the comments. But for now, thank you very much for watching. I am your next door net admin, and we will see you next time.